Alrighty. I think we're good to go. So, Roll SK here, Bitter Old Goons Gaming. Today we're fixing, or at least troubleshooting, this Neotec NT-2701 arcade chassis. I think I might already know what the problem is. And it might be a counterfeit transistor. I found a bad solder on one of the capacitors on the neck board, but that's probably not the issue. I think the issue is more this horizontal output transistor, which there are known fakes for. And we're just gonna see if she blew. Everything around it looks pretty good. I'm gonna grab the good ones first, as in the ones that aren't fried, that I have new ones of. Which I have in my hand. Let's see. Okay, I got them. Okay, so we have here an arcade chassis. Oh, hi, Alex Burks. How are you today, bud? We're doing repair work. And I think we might have a bad transistor. I'm going to gently flip this over, and I'm going to test the resistance of the transistor. And we're looking at actually this one right here. And it should... Oh yeah, she's fried. She's fried. Okay? Because we should actually... Oh yeah, look at that. No resistance. Hey, Dark Avenger. Yeah, we blew a transistor. So that's an easy fix for me, actually. Because I knew it was going to be the fucking problem. So I'm going to do a little drawing here for you guys to demonstrate how I know this thing's fucked. Where is my pen? Where's my pen? Where's my pen? Where's my Sharpie? I think I threw it into a bag. Ouch. Okay, I almost unplugged my webcam. But I'm going to show you real quick how to tell if a transistor is bad based on how transistors are built and what they're designed to do. They're a switch, so they're supposed to restrict current flow unless they're switched. I am just up walking around looking for a pen I can... Yeah, this one should work. Hopefully this one works. Let's take a look. So... hopefully that's big enough to see. Now, a transistor has 3 legs, typically. And I might be drawing this incorrectly, but that's not the point. The point is that there's a diode in a transistor that should restrict current flow in one direction. Now, here's a replacement. I don't know if it's any good or not. But this is what you should see. I'm going to flip this around. And we're going to test the legs on this using the resistance reading of our multimeter here. And you will see that I get 37 kilo ohms from this leg to this leg. And if I reverse those, I get no flow, no current flow, max resistance. And what that means is there's a diode in there. Same way this way. That's what a good transistor should show you. It should show like high resistance, in this case 37 kilo ohms through one side and no flow through the other side. And if we test the transistor that's on here, now would be a good time to turn on my soldering iron. So now we're going to test this horizontal output transistor, which is what blew on this thing originally. And you will see that we have no resistance. In either direction. Meaning, this thing is fried. We've got a blown horizontal output transistor. That is actually a pretty easy fix. So all we're going to do today is remove that and install one of the others I have, which hopefully are not a counterfeit product either. I do have a better source for these if this one blows. So we'll give it a try, pop it in and see if the damn thing works. I am currently just walking over to grab a screwdriver to pop out that old transistor. As soon as I could find the damn thing, and we'll swap that puppy out and test it and see if anything blew along with it. Unfortunately, sometimes when things short out, they tend to take some components along with them. Okay. I'm just going to go ahead and there's a little nut that holds this transistor to the heatsink. And anytime you're working on an old chassis like this, you have to be very careful when you flip it over. All these heat sinks are held in by solder, and if you drop it or put too much pressure on them, you can break those solder leads, which is going to give you more problems. But I digress. Just going to gently unscrew that screw. Make sure we take the nut with it. And yeah, I do it. We unscrew stuff. Now the horizontal output transistor is the part of the CRT chassis that causes the beam to go left and right. And does that at whatever frequency the particular arcade chassis is designed to do it at. And you know, there's 15 hertz, 34 hertz, and a bunch of others. We're mostly familiar with like a 60 hertz, stuff like that with displays. These old arcade chassis have a variety of different frequencies they like to run at. In our case, we've got the manual, which is good. And the manual actually tells us the difference. You know, so we've got the NT-2701 that runs at 15 megahertz bandwidth, 30 megahertz bandwidth, and 45 megahertz bandwidth accordingly. And what that indicates is actually, that's the bandwidth frequency this thing can sort of more or less operate at. Much like a modern computer monitor, it's only going to run how much bandwidth it can accept. So if you look at this, you see 15 megahertz video bandwidth, 560 by 240, 30 is 640 by 350, and 45 megahertz bandwidth is all the way up to 640 by 480. And this is the frequency of the monitors it drives. And you can see 15, 25, and 31. So the horizontal output transistor causes that causes the electron beam to fire across the screen left to right, 25 kilohertz. Anyway, I digress. This is going to be a relatively simple fix, hopefully. And I hope I have enough lead on my camera to show me actually plug it in and test it after. But for starters, we're going to have to go ahead and pop this old transistor out and replace it with one of the replacements I have. And I must have known I'd screw this up because I bought 4 of these transistors. I also bought 4 of them because after reading on the internet, I found there was quite a few duds out there floating around for cheap. And I bought on eBay. So, you know, my bad. So we've taken out the mounting screw for that transistor. Our soldering iron is good and hot. We're going to use a soldering wick to desolder transistor right here. And this is a fluxed soldering wick. I will actually have to snip. We have a fresh piece. Now, solder wick, if you're not familiar with the term, it's just braided copper ribbon, and all it does is it absorbs the solder. Which makes components a heck of a lot easier to pull out. Yeah, that's working well. That's exactly what we see. So if you're wondering how you learn how to do stuff like this, I am not an electronics technician at all. I more or less figured out how to do this by reading online and being kind of technically minded in general and having some basic soldering skill. But that did not prevent me from buying cheap parts, which I will never do again. Go suck up that solder on there. And sucking up that solder means it'll give us a clean thing to solder to when we put the new one in. And will also make it easy to pull out. And that is what she said. Okay, so we got 2 of the 3 legs done. And we're also going to test this transistor one more time once we pulled it out to make sure that we're not reading a short. That's caused by another component failure. Some capacitors, ceramic ones, for example, when they short or when they blow, can cause a short. I suspect quite heavily that what I have here is just a bad transistor. It worked for about a week, and then I decided it was going to quit. Of course, it decided it was going to quit when I had company over, which is quite embarrassing. Anyway, we've desoldered that connection. That soldering iron away. I'm going to gently flip this over. We're going to pull that bad boy out of there. Okay, there we have it. There's the old one. Chock full of goodness, of thermal compound. And we've elected to use PC thermal compound because I have it readily available, non-conductive. Works fine. Okay, so we have our potentially bad transistor. Let's use our resistance testing again. Oh yeah, no resistance. Go the other way. Yeah, she's fried. She is fried, folks. And once again, if you compare it to a good one, at least what I hope is a good and not a shit counterfeit one, we get 37 kilo ohms in one direction and nothing in the other, which means this one's good, that one's toast. Well, let's go ahead and we're going to bend this leg just so we know it'll fit well. See what I did there? Great. Goodbye, cheap Chinesian part. And try not to get thermal compound all over the place. Line up this insulating pad that's on here. And while I'm at it, I'm going to actually just get a little bit of cleaning solution here. Oh, yeah, thanks. No, I know you're still on. Thank you, Digital Multimeter, for reminding me to shut you off. Okay, Q-tips. Got them. And we're just going to give that a little bit of a clean. How are you doing today there, Dark Avenger? Now, a proper way to do this would be like a methyl alcohol, an alcohol base to clean that up. I don't have any handy. And just looking at this, I've got more than enough thermal compound on here, so I don't need to add any more of that. I've got that somewhat cleaned up. I'll try and pop this puppy in here. We got 2 of the 3 legs in there. I'm going to use a screwdriver to just gently pop that one into its... there we go. Like a glove. Just working around as always. Yeah, me too, bud. I've been putting off doing this stream all day because I was afraid that I was wrong on what I figured the problem was. But I wasn't, so I'm happy. We'll pop in the replacement. See if that blows. And if that bugger doesn't last, then I'm going to have to order good ones. Now, this transistor is a name-for-name replacement for this component on this board. But if you look on arcade forums, there's better quality ones out there that are more robust. And if this bugger doesn't work, I'll have to spend the $7 US. And then the $14 US shipping to bring in a higher quality component. Now, if you were screwing down a transistor like this into a heat sink like I am, don't over tighten, break shit. You don't want to crack the transistor. I'm mad at you. BU2532AL. Don't think you're a counterfeit. Okay, that's in place. Now we can flip it over and solder it together. I'm just going to do a quick visual inspection of the board end to end. Now, I did a cap kit on this, so I ended up replacing most of the capacitors. I just want to make sure that none have decided they want to not be on here anymore. I think it's okay. And I think I'm also, while I'm looking at this, I'm going to just slightly turn down the B+ voltage on the board, which should give it a better chance at not frying if the B voltage was too high. Phase V subsize V line's fine. Gonna check all these heat sinks. They all feel pretty solid. No play in the flyback. Okay, I think we're good to go to start soldering. Might be my fastest repair stream ever. Okay, good. Got our 3 legs sticking out there. I'm going to probably clip them after I solder. Just wondering where my snips are. Where are my snips? Oh, geez, and there's my Sharpie. Been looking all over for that. Thermal paste, etc., etc. 1 second, folks. I gotta find my snips. Snips, where are you, Snips? Where'd I put you, little buggers? I got these real low profile ones I like to use for this. Now, if I could just remember what the hell I did with them. I got a real problem with putting my tools in different spots every time I do some work. Ah, there they are. Yeah, of course, they're in the junk parts bin. Why would I put them there? By the way, folks, if you're watching and you have any questions about what I'm doing, I'm happy to explain. Good. Help Dad fix his snowblower today. Got a foot of snow. All right, let's solder that puppy in there. I'm gonna put a little bit of flux on there. Now, what flux is, folks, is it's a corrosive chemical that helps the solder adhere to metal. A little bit goes a long way. A little dab on there. That's all you need. Just need a little bit. It'll run when you apply heat to it and make a big mess. So be prepared for that. All right. Okay, now we can start soldering. Now we have leaded flux core solder. And we'll just do one leg at a time. Like pants, one leg at a time. Unless you're an acrobat. So here's a hint for solder, folks. Flows to heat. You don't necessarily want to put the solder on the iron. You want to heat up the component and let the solder flow to the iron. And that will ensure you get the best connection. Okay, that one looks good. That one looks good. Come on now. Sorry for the binging. I apparently left Facebook open on my streaming rig. Low in there, buddy. Get on in there. Out of my way, iron. There, that looks good to go. Make sure we wipe off the solder tip so we don't burn flux on it. Make it bloody useless. All right. Now we're just going to snip off the extra little bits. So here's a pro tip on snipping off little bits like this. Take them off your damn board. Because last thing you need is something shorting out because you left a little snippet of metal on there. Okay. Okay, that's it. I'm just going to fire up the digital multimeter, set it to 60,000 or 60 kilo ohms. And yeah, that looks good. That looks good. Oh, that's so much better. Oh yeah, that's proper. Okay, so I'm going to attempt to relocate my camera. So I apologize. I'm gonna well, no, I'm just gonna pick it up and move it. So be prepared for that. Hopefully this doesn't kill the stream. Yeah, this is me walking through my house with a 30-foot USB cable. And I'm gonna bring it over as far as I can get it. Okay, pretty good. That's pretty good. Yeah, let's see if we can set it somewhere. Where do I want to put you? I'm just going to see if that's going to work. 1 second. I'm just checking my stream. Go down a little bit. And for your viewing pleasure, I'm going to turn this beast around and turn on some lights. And turn on some lights. You're now staring at my living room. Hope that's as exciting for you as it is for me. Okay. That seems like it's going to work out pretty good. So we have here a 2004 Golden Tee. One I've almost sold. We're going to spin it around so you can see the inside. Means I need to lock in the control panel to lift it. I will then have to immediately unlock so I can connect the audio visual part there. Okay. Oh God, it's heavy. Oh, it's heavy. God, these things are monsters. I'll tell you that. And yes, I am wearing pajamas. It's perfectly normal. Perfectly normal for me after doing my chores. How's that look? Does that look okay, folks? Now we'll bring the chassis over. Fire off that soldering iron. Hold together, baby. So there's going to be 4 or 5 things I need to plug in on this. For example, I've got the neck board. You know what? I got a better idea for this. I'm going to move the camera again. 1 second. How's that for a view? Maybe that's a little bit better for you folks so you can see what I'm doing. See if you can see what I'm doing. Yeah, that looks good. Alrighty then. What are we doing next? Yes, well, 4 or 5 things to plug in. You've got, this is the yoke connector. That controls the windings around the yoke that help with focus. We've got the ground. This goes to the neck board. And we've got the this positive. This might be actually for degaussing. And what we need to do is we need to feed that panel in there. At the same time, I'm also going to slide this control panel out, give myself a little bit of room. I need to unlock it now that I've locked it. Now the control board on this thing slides all the way out with the controls, which is real handy. But it has an adjustment on it for the monitor that I'm going to need to run wires to. Okay, good to go. That's been pulled out. Now we just got to feed this thing back in here. Now, depending on the style of your arcade cabinet, this can be easy or hard. Step one, get all the wires out of the way. Now in my particular one here, I've got to feed in this cable first, which is for the adjustment that's on the main board there up front. And then I have to feed it in from underneath. It won't fit in past the neck board or past the yoke unless I do it this way. So when you're doing this, gotta be real careful. You're not gonna scrape off any components. There we go. And this one's meant to mount in here, so it actually sits on here quite nice. Pull the ground and the degaussing out of the way. The power cable out of the way. Good. Good. Power connection, good. Everything's good. Got this one. I'm missing something here. Where is it? I am missing part that connects to signal. Should be right off here. You hiding? How am I not seeing this? Big 6-pin connector. Oh. Am I just blind? It's here. Ah, there it is. Yeah, this. That's the connector for the signal. So, this is the high voltage connection for the actual CRT itself. There's a little spot up top it pops into. Just barely make out. Oh, bloody heck. I'm gonna go ahead and disable that YouTube there. Where is it? This is my office now. There we go. That's what I was looking for. Let's plug it in and see if the damn thing works. I'm going to put one sort of holding screw in place for now. Keep it in its spot. Because if this doesn't fix it, then I have to take it out and try again. I'm pretty sure it's going to work though. Pretty sure. Don't slide back on me. Know where you want to be. Right there. Putting it in place also sort of keeps the damn thing from sliding around too much on you when you're plugging things in, which is handy. Okay, it's there. Next, we'll go ahead and pop this into the tube. Note that this has been fully discharged. These things can carry quite a kick, enough to kill you. If it's still voltaged up, that's in. Take our yoke connector. It only plugs in one way, which is handy. Can't really screw that up. In she goes. Next, we'll plug in dowsing ring. There. And that just leaves the ground. Put on now is that just goes on the yoke or the neck board connector. If you're going to do work like this yourself, my highest recommendation is you take photographs where all your wires go. And we're just pop that neck board on the end of the yoke. There we go. Signal here. Plug that in. Take our adjustment cables. I'm going to just feed them through to the front. Part you're not going to see because it's around the front. And these only plug in one way, so that's not really a big deal. That's in there. And stepping on screws I left on the floor. Good job, me. Finally, we've got our power connector. Give everything in one last go over. Ground's connected, degaussing's connected, power's good, signal's good. Flyback transformer is going to the CRT. Neck board's on, solid. Okay, moment of truth. Bring the camera around. See this? Well, I'm gonna have to move it. 1 second. 1 second. I'm just gonna turn this around slightly. That back in there. This. Just gonna turn it around a little bit. Lock that in place so she doesn't move. Oh, there goes the back of it. That's okay. No damage there. Okay, moment of truth. My sister bought me these PJ pants. They're sweet as fuck. Okay, so you folks are watching. Look for smoke. Here goes nothing. Oh, yeah, baby. That's what we're looking for. Right there. You silent death. We have success. Great success!
I play with passion. I love to win. Golden Tee is my game.
See, we need to do a little bit of adjustment on this.
Driving the green. Golden Tee is my game. It's your game.
Ooh. We have a success. It seems a little bit dark right now. I think that's probably fine. It'll, as it warms up, it'll brighten up quite a bit. The focus is a little bit off. Leave would be. Nope, wrong way. Okay. Well, geez, that's it, folks. I mean, that's working. So that's what we want. So I mean, I'm almost pretty much done. I'm gonna shut it off, and I'll just show you guys some of the routing of the wiring and stuff like that, because that's kind of neat. 1 second. Oh, that's... Welcome back.
Welcome to Golden Tee Golf. I'm passing along. With me is Neotec.
Golden Tee Golf.
Great to be with you.
One of my favorite games. Okay. So now that the thing's been fired up, I'm gonna have to be really careful in there because it's gonna have all kinds of high voltage shit I don't want to touch. But we're just gonna be putting the screws back in, and that's really all I need to do. Now, how am I gonna set this camera? 1 second, folks. Let's see if I can get this to work for me here. Face down. Face down, camera. Move you over a little bit. Is that gonna work for me? Is that gonna work for me? Down more. Try that. You guys can see that. No, not really, eh? Come on now. Come on. Look down. It's junk. Yeah, that might actually have to be good enough. Well, what is my dog barking at there? Let's try this maybe. I want to show you guys the insides. What is she barking at? Oh. Dog walking by. Neighbor. Okay, so this is the inside of a Golden Tee arcade cabinet. And at this point, all I need to do is just feed the wires back through the looms that I pulled them out of when I took this thing out for service. It's really not that difficult to do. In fact, that's pretty much it. I'm gonna squeeze that one in there real quick. There we go. Great, easy peasy. And these are all extra spare wires we don't worry about. But yeah, she's fixed. That's mounted in place. I put the backpack on it. And when my buddy comes to pick it up, he's good to go. And when it blows next time, I know what to fix. Easy peasy. Oh, before I put the back on, I should put the goddamn back in. You folks really don't need to see that, though. Just putting screws in is not that exciting. Yeah. I'm Roll SK. And that was a really quick and dirty fix of Friday because I knew what the problem was, which is not always usual. And we got her fixed. So, you know, thanks for watching this very brief repair stream. And we'll see you soon.
Groovy.